Hello and welcome to Unit 4, Electricity and Magnetism. Today I'm just going to go through an introduction to electricity, some of the stuff you might know, and some of the stuff I want to review and make sure everyone's on equal ground in terms of terminology. So, today's learning goal, I can explain different concepts related to electricity. So normally, go through and I'd have a discussion as to what is electricity or what is your definition of it or explanation. What it essentially boils down to, what is electricity? It is the flow of electrons. The flow of electrons. That's what I want to keep it at this point. Okay? So electricity is the flow of electrons, and we're going to talk about exactly how that works in different situations and the different types of current out there. So law of electric charges. Should have from grade 9 or 10. This should be something that you do know. Opposite charges attract each other. Opposite charges attract each other. So positive and a negative. Those electric charges are wanting to get closer to each other. Like charges repel each other. Okay, so if they have the same charge, they're going to push away or repel. Third one is charged objects attract some neutral objects. Okay? So it is possible or positive to attract a neutral or a negative. Usually depends on the difference in the actual charge. So electric charge transfer. The transfer of charge from one object to another is caused by a large difference in the number of unbalanced electrons in the two objects. Okay, so if one object has a large buildup of electrons and another one doesn't have that large buildup, there's going to be that transfer of electrons from one to the next. So I'm going to talk about quickly conductor versus insulator. We talked about it a little bit in the last unit, but that was more dealing with heat transfer. Still very similar. So our conductor, it's a material that readily allows the transfer of electrons. Transfer of electrons. So currently, one of the more common materials right now would be copper. The newer houses or newer construction have what we call copper wiring. Some of the older houses will have aluminum in them. So they're excellent conductors of electricity. And then you get your lesser pipes, steel, and so on and so forth. Okay? So most metals will conduct electrons to one degree or the other. Your insulator then. Insulator. This is a material that resists the flow of electrons. Flow or transfer of electrons. And if you have occasion to come see an electrician or meet an electrician, you notice the screwdrivers, all the handles are rubber. Rubber is a good insulator. It doesn't allow for the transfer of electrons through. It's one of your better ones. And air to a certain extent, and there's many others, which I'm not going to go into too much detail. But that's the difference between a conductor and an insulator. So as we're going through, we're going to talk about the two different materials. So charging by friction, contact, and induction. I'm going to keep this fairly simple. You should have seen some of this in your earlier science courses, and if not, this will give you a feel for sort of static friction, how static friction works. So friction, basically the electrons are stripped away by one material from another. So we say that the one material has a greater affinity for electrons. So basically, as the two materials rub together, so it doesn't matter in this case what the materials are. So I'm just going to say that we are rubbing in this direction. If one has a excessive amount or there's a difference between the two, then put a couple here, and I'll just put 2 on this one. What happens then is that those electrons will be stripped away by the other material, so that in phase 2 then we pull those objects apart from each other. The one just has 3 electrons now, and the other one now has 4. So that friction just strips the electrons away by one material having a greater attraction or wanting those electrons. Okay? Contact. When 2 charged, I know it doesn't actually have to be when they're charged. When 2 objects come in contact, their charge will balance. So let's go back to the pith balls. So stage 1, I've got a pith ball here, and a pith ball here. So let's give this one 1, 2, 3, 4, 5, 6, 7, 8, and we'll give this one 1, 2. In stage 2, they're going to touch. So stage 2, we're going to force them to touch. And what happens, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, is that they're going to add themselves up and they're going to say, hey, there's 10 of us, that means everyone's going to get 5. So this electron will jump ship, this electron will jump ship, maybe that one will as well. So that stage 3, they then become or have the exact same charge. So stage 3, they come apart. Now we've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and that's when you have that contact, you're charging by contact. Okay, so they balance themselves out. And the last one is by induction. It's the more trickier one to explain. I'll do my best with diagrams here. So induction. And I'd say, I'm going to keep it simple, the process of forcing electrons out. I'll put that in quotes. So we're going to find that probably in a textbook. So going back to diagrams, this is what we have. Stage 1. So I'm going to have, I'm going to go with a negatively charged object here. So 1, 2, 3, 4, 5, 6, 7, 8. Let's go 10 here. And my second one is only going to have 1, 2, 3, 4. Okay. So stage 2, we bring them close to each other. So I'm not going to do another diagram. So bring close, but do not touch. So we don't want them to touch because I don't want them to have a balanced charge. So what happens then in stage 2 is that you have this, in this case, highly negative one, and this one's still not touching. So here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The charges in this object here, they've spread themselves out evenly. They know that they have to share the space, so they've found kind of a happy medium. The electrons in the second one, though, aren't very happy with the proximity coming close to them. So all of a sudden they move over to the other side because they want to get as far away from those electrons as they can because they don't want to, they repel each other. So what we do then is we provide an escape route. Again, I'll put that in quotations because again, you're not going to find that terminology. So I'm going to take my finger, and again, you can make fun of this, or you're going to make fun of it. So I better label that finger. Okay, and what happens then is those electrons say, aha, we can get out of here because there is way too many electrons there. So in stage 3, that we then separate them, give them their space again. So I move this one way over here. I'm going to move this one way over here. So we got the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this guy here only has one left. Okay, and you could, I mean, we can force out as many as I want just for the diagram. And what this does is it allows you to create a positive charge. This process. So the process allows us to create a positive charge. Okay, so there is your by induction. Okay, so again, it's grade 9 material or grade 10. I forget when it's taught. So if you've seen this all before, that's good. I'm just going through and refreshing your memory. Current. What is current, or what are we looking at? The definition of current is the rate of electron flow. So that is electrons moving from point A to point B. What do we use for current? What is our symbol? We use I. Current, we use capital I as our symbol. What is the unit for current? It is amps, or amperes. Guess I better use the official name. And it's just an A for the units. Well, the formula for that current is as follows. It is I divided by QS. Excuse me. So I, put the capital on there, I is your current. Q is the amount of charge. And I can't remember if that's coming up in a future slide, but let's do it right here. So Q is equal to NE. So there's a formula for Q. And those values then, N is the number of electrons. And your E is the charge of electron. That is constant. And finally, S. And I don't understand, and what I'm going to do here, maybe I'm going to change this back. Get rid of the S here. Let's make this a T. And I have less confusion later on. T is the time in seconds. Okay, so it tells you how much current is going by, or how much charge is passing a particular point in seconds. Okay, so your formula then could also be written as I equals NE over T as well. Okay, so here we are. We're now starting our formula sheet, or cheat sheet, whatever you want to call it. And there you go. There's your first formula that will go on there. Now let's talk about DC and AC current quickly. Actually, that's kind of it's been pointed out to me. This is a bit of an oxymoron here. It should be just DC versus AC, because DC is direct current. That is the flow of electrons from posts. We'll talk about that when we get to the end of it. Posts on a battery. All right. I'll finish up this last note or the rest of this note in the second part of the video, but it's just finishing up, going through some definitions. All right.